All right, so if we have a point x comma y in rectangular coordinates, we can write that point in polar coordinates as r comma theta, where x is r cosine theta, y is r sine theta, and r is the square root of x squared plus y squared. Now these formulas we've been using all semester, so if you look at the picture here on the right of your screen, this distance here is x, and this distance is y. So using Pythagorean theorem, that's where we get that r is the square root of x squared plus y squared. And that's also how we get that x is r cosine theta and y is r sine theta. Those are just coming from right triangle trigonometry. This is true in the first quadrant, but it's also true in any quadrant. And theta is just any angle in standard position whose terminal side is going to go through the point x comma y. That's just using our definitions of the trig functions cosine and sine. All right, so let's try converting. So here's a point P equal to 3 comma 2 in rectangular coordinates. Let's convert that to polar coordinates. Well, if I know that my point here is 3 comma 2, then using the trigonometry that we know that tangent of theta must be y over x, which in this case is 2 over 3, and theta is an angle here in quadrant 1 since the point 3 comma 2 is in quadrant 1. So this is my point as xy. So how could you solve for theta? Well, you've been doing this for a couple sections now. We could just take tangent inverse of 2/3, and that gives me 0.588 in radians. And to find r, we just use the fact that r is the square root of x squared plus y squared. So here that's the square root of 3 squared plus 2 squared, which is the square root of 13. So the polar coordinates for this point are square root of 13, comma 0.588. What about going in the other direction? So we could use degrees or radians. So I want to switch back and forth just to make sure you become comfortable with both. So here I've expressed my point in polar coordinates using degrees. It's 5, 210 degrees, and I want to convert that to rectangular coordinates. Now this is even more straightforward because we have formulas for x and y in terms of r and theta. Remember, x was r cosine theta, and y is r sine theta. So we're just going to plug in our values for r and theta. Here's r, and here's theta. So I get x is 5 cosine of 210 degrees, and y is 5 sine of 210 degrees. This is an angle that you know, 210 degrees, so we should be able to solve this pretty quickly. X is 5 times negative root 3 over 2, and y is 5 times negative 1/2. And then finally, you just want to list this as an ordered pair. So the point P in rectangular coordinates is negative 5 root 3 over 2, comma negative 5/2. All right, when you are converting points from rectangular to polar, just be careful to pay attention to which quadrant you're in, because it won't always work out that you can just take the angle that you get from taking tangent inverse of y over x. So sometimes you may need to adjust to get the angle in the appropriate quadrant. All right, let's look at how we might sketch a polar equation. So a polar equation is an equation involving r and theta. So something like this, r equals 3 cosine of theta. And just like when you first learned a graph in rectangular coordinates, we're going to start by plotting points. Okay, so I want to plug in values for theta and solve for r and then plot those points. So if theta is 0 degrees, then I get 3 cosine of 0 degrees, which is 3 times 1, or just 3. So I want to plot the polar point. Now I've written my theta and r, theta first and r second, but of course the point in polar coordinates has the form r comma theta. So the polar coordinates are 3 comma 0 degrees. That's the point that we want to plot. And so what that means is we're going to think about where 0 degrees is, and we're going to move 3 units in that direction, and so there that point is. When theta is 30 degrees, I get 3 times cosine of 30 degrees, which is 3 root 3 over 2, which is approximately 2.6. So now 30 degrees is the same as pi over 6, and I'm going to move 2.6 units in that direction and plot my point there. All right, what about when theta is 45 degrees? Oops. I'll get 3 cosine of 45 degrees for r, which is 3 root 2 over 2, and that's about 2.12. And so I'm going to move 2.12 units in the direction of 45 degrees, and that gives me this point here. When theta is 60 degrees, I'm going to get 3 over 2 for r, which is 1.5. And so there's that point. And we just want to keep going. So when theta is 90 degrees, I get 3 cosine of 90, which is 0. So that's going to put me at the origin. Let's do another. When theta is 120 degrees, I get negative 3 halves. So I'm going to move in the negative opposite direction, and that's going to give me the point down here. If theta is 135 degrees, I get 3 times negative root 2 over 2, which is approximately negative 2.12. So that's going to shoot me down into quadrant 4, and there's that point. When theta is 150 degrees, we again get a negative value for r. I'm going to get negative 3 root 3 over 2, which is approximately negative 2.6. Again, that's going to shoot me from quadrant 2, from quadrant 2 down into quadrant 4. And so there's that point. And finally, when I plug in theta equals 180 degrees, I get negative 3. And that's going to put me back at the point that I started at, right there. All right, so the last thing we want to do is connect all those points. And so here we go. We've drawn a circle. All right, let's look at this graph. So I want to sketch the graph of theta equal to pi over 3. So here, I'm going to plug in values of r and think about what theta would be. Well, the equation is theta equals pi over 3. So regardless of what r is, I'm always going to get theta equals pi over 3. So let's just plug in some values. If r is 1, theta is pi over 3. So I want to plot the polar coordinate 1 comma pi over 3. There we go. Say, let's let r be 2, then theta is still pi over 3, so now I'm going to go out a little bit there. And if r is negative, let's say -4, I'm going to plot -4 comma pi over 3. And you can see I'm just going to get all the points here on this line that goes through the terminal side of the angle pi over 3. So we just get a line here. Now we could write down the rectangular equation for this line. How could I do that? Well, I know that tangent of theta is y over x. So let's just plug in theta. So tangent of pi over 3 is y over x, which means that √3 times x is y. So this is a line with slope √3. In general, if you have an equation of the form theta equals some value a, that's always going to give you a line. Okay, so that's one that you should recognize. Now what if I fix the value of r? So here I want to sketch the graph r equals 2. So I'm going to let my angle theta vary, and r is going to stay fixed at 2. So when theta is pi over 6, r is 2. So we're going to plot the point 2 comma pi over 6 here. When theta is pi over 4, r is still 2. So I'm going to get the point here. When theta is pi over 3, r is still 2, so we're going to plot that point. Now you should see what's happening here. These are all points on a circle of radius 2. Now I could also rewrite this equation in terms of a rectangular equation. Well, this you should already know. The equation of a circle has the form r squared equals x squared plus y squared. And in fact, in our polar coordinates, r squared equals x squared plus y squared. So we're just going to use that fact and plug in 2 for r. So there you go. This is the circle with radius 2. X squared plus y squared equals 4. All right, so this one and the previous one you should recognize these as circles and lines. This is a little more complicated, so I want to just plot some points to give you an idea of how you would graph this by hand, and then we'll talk about how to do it on your calculator. So again, I just want to plug in values for theta. So let's start with 0. If I plug in 0, I'm going to get 3 sine of 2 times 0, which is going to give me 3 sine of 0, which is 0. So I need to plot the point in polar coordinates 0, 0, which is just at the origin. Now what if theta is pi over 6? Well, that gives me 3 sine of 2 times pi over 6, which is going to be 3√3 over 2, which is approximately 2.6. So I'm going to go in the direction of pi over 6, and I'm going to move 2.6 units out. And so there we go. When theta is pi over 4, I have 3 sine of 2 pi over 4, which is going to give me 3. So I'm going to plot the polar coordinates 3 comma pi over 4. When theta is pi over 3, I'm going to get 3 sine of 2 pi over 3, which gives me, again, approximately 2.6. So I'm going to move in the direction of pi over 3 and then out 2 pi over 6 units, about there. Now when theta is pi over 2, 3 sine of 2 pi over 2 gives me 0. So that's going to put me back at the origin. So if I'm sketching my graph, it started at the origin and it moved up and through these points and then back here at the origin. Okay, so it looks kind of like the petal of a flower. Now we can keep going, so I'm going to turn the page. And so here's the first loop that we sketched. I'm just going to show you the next values. So let me show you all of them and then we'll plot those points. So you notice when theta was 2 pi over 3, that's in quadrant 2, I got a negative 2.6 for r, which shoots me down into quadrant 4. Okay, so that was this black point here. Let's see if I can, there we go. And when theta was 3 pi over 4, I got a negative 3, so I'm going to move in the opposite direction of 3 pi over 4, and that gives me this orange point down here in quadrant 4. And then we did the 5 pi over 6, and that gave me this blue point down in quadrant 4. And finally, when we plug in pi, we're going to get 0, and that puts us back at the origin. So what we get is another loop like that. All right, now we could continue to do this. And what you'll end up with is a 4-leafed flower, or a 4-petal flower. Now let me show you another example on Desmos. So the graph that we just graphed is called a polar rose, and so in general the polar rose has the form r equals b sine a theta. So for us we had 3. Let's see if I can get 3 here. For b, and a was 2. There we go. So there's the 4-leaf polar rose. But you can see as I adjust my b value, that's going to move it in and out. And as I adjust my a value, all sorts of funny things can happen. All right, so I'll link this in the notes too, and you can sort of play around with the pictures you get. All right, so how are you going to graph this though on your calculators? Well, first you need to make sure that your calculator is in radians mode. You know how to do that. And then put it in polar graphing mode. So you're going to hit the mode button, and I've just highlighted the 2 parts that we're concerned about. So make sure that the radian mode is highlighted, and then you should have the line under that. You have the choice of what kind of function you're going to graph, and so you want the POL to be highlighted for polar. All right, so go ahead and do that, and then hit the y equals button on your calculator. And so that's going to take you to this screen on your calculator. And in the R1, I want you to type in the graph that we just graphed, 3 sine 2 theta. Now your calculator will automatically switch to theta, so you'll hit the same button that you hit for x to get that theta. All right, now once you've got that typed in, you can go ahead and hit the graph button. You may or may not be able to make out the graph depending on how your window was set. So let's talk about how to adjust the window if you need to. So you're going to click on the zoom button at the top of your calculator. And option number 7 is zoom trig. So as a first start when you're graphing these, this is a good way to just get a baseline, and then we can adjust the window if we need to. So let's talk about how to adjust the window. So you're going to hit the window button to the left of zoom, and that's going to take you to this screen here. So what you see in the first 3 rows, theta min, theta max, and theta step. That's describing what's happening to the theta value. So this is the standard setup for the option 7, the zoom trig. So the min value for theta is 0, and you should recognize that 6.283, that's 2 pi. So what it's doing is it's sketching the graph for values of theta from 0 to 2 pi. And the step is telling you sort of how frequently it's going to calculate those on the calculator. Now, the x min, x max, and x scale, those are just the same as when you're graphing rectangular coordinates. So it's telling you how big you want the window to be in the x direction. So the minimum x value and the maximum x value you want, and again the x scale, how often you want it to make tick marks. Same idea with the y. So there's an arrow pointing down to get to the y max and the y scale. I didn't bother putting those on the screen. All right, so let's try adjusting the window here. So what I want you to do, let me get to it, is adjust the theta values to go from 0 to pi over 2. Now, if you remember when we were sketching this graph, from 0 to pi over 2, that sketched our first petals. And so we just want to be able to see that happen on the graphing calculator. So go ahead and change that theta min to 0 and the theta max to pi over 2. And then I also want you to change the x min to -4 and the x max to 4. And you can leave the x scale alone. Now that'll just draw the coordinates like we had them drawn just a little bit ago. All right, so go ahead and do that and then hit the graph button on your calculator. And so what you should see is something like this. So it's going to draw just that first petal when you restrict the theta values from 0 to pi over 2. All right? Okay, in general, you're going to want to graph from 0 to 2 pi. So usually just clicking that zoom and then option 7 should give you a good picture of your polar graph. For the purposes of this class, I want you to be able to plot polar points, so plot polar coordinates, and identify a polar graph using your calculator as an aid. All right? You should recognize the graphs of the form r equals a, where a is some constant, or graphs of the form theta equals b, where b is some angle. All right, so I just want to show you a couple of pretty pictures, and these are all from your textbook, just to show you some of the cool things that you can get when you're plotting polar equations. So here, this is the equation r equals theta, and we're just graphing it for values of theta that are greater than or equal to 0. And you can see the red part is that graph, and it's just a spiral out, right? As theta increases, so does r, and so we keep spiraling out. Here are some more. So there's your spiral. We saw the circle, r equals a cosine theta gives you a circle, and so does r equal a sine theta. In both of those cases, a must be positive. We can get all sorts of roses, so we can get a 3-leaf rose by graphing r equals a cosine 3 theta. Again, a must be positive. And we can get the 4-leaf rose here, r equals a cosine 2 theta. And the one that looks like a figure 8 there is called a lemniscate, and we get that from the equation r squared equals a cosine 2 theta. And here are just a couple more. The cardioid looks like a little heart, so that's where the name cardioid comes from. That has the equation r equals a times 1 minus cosine theta. The limacon, you can imagine sort of pushing that out to the right. So if I took that middle one with the little loop on the inside, if I shove that out to the right, it eventually could flatten up to become the one on the, I'm sorry, if I shoved it out to the right, it could flatten up to become the picture on the right. So both of those are called limacons. All right, so I don't expect you to have these memorized, but you should be able to, given an equation of one of these, you should be able to plug it into your calculator and see what the picture looks like, and you should be able to identify the correct graph if I gave you some options.